Hi, it's Carly McAvoy. I've been doing problem solving all day. This is video 9, and this one we're going to look at solving similar triangles using proportions and a couple of other proportion problems and some percentage problems that involve like sales tax. So when you have similar triangles, it just means triangles that have the same shape. They're proportionate, but they're not the same size. So I've got two proportionate similar triangles there, and you can see that the corresponding sides, 5 corresponds to 60 and 3 corresponds to x. Okay, I didn't label these proportionate to number wise, it's just random drawings. But let's suppose that they were similar and that those sides were proportionate. We can set up a proportion to solve that. And so I can, there's more than one way to do it, but I can say 3 is to 5 the same way that x is to 60. Because those are similar triangles, they're proportionate, I can set that proportion up. Now to solve that, what I do is cross multiply, so I have 5 times x, and I cross multiply this way, and I have 60 times 3, which is 180. Once I've multiplied, cross multiplied like that, divide both sides by 5 to find out what x is. So 5 goes into 180, goes 32 times, what is it? You don't have to do it in your head. I was going to do it in my head, but my brain after 9 videos apparently has stopped working. And you know what? It's okay. I got 36. I was getting close, but not there. I want to talk about that for a second. So in my classes, don't ask you to do everything without a calculator. You can always have a calculator nearby. I don't want you to make a mistake like 180 divided by 5 and get 32 and miss a whole problem. Check it on your calculator. But it's understanding what you're looking for and saying, does that answer make sense? That's really important. So one of the things I could have done was just say, well, 5 times 12 is 60, so 3 times 12 has to be 36. That's another way to look at that, right? But anyway, you could have also set this up this way. You could say this side is proportionate to that side, so I could have said 3 to x and then 5 to 60. And if you did that, if you cross multiply, look what we get again. We get 5x equals 180. So you can set that up in more than one way as long as you're consistent across there. Okay, in the second one it says Bridget purchased 23 concert tickets for a work function for $402.50. How much would she have to pay for 50 similar tickets? So we're going to set this up, and when I'm setting up a proportion, I try to remind myself what I'm comparing. So like I would write cost to ticket, something like that. And then I would set that proportion up. The cost was $402.50 for 23 tickets. And then I would come over here and say, now I want to know what's going to cost for 50. And that's how I know the 50 has to go on the bottom, because I put tickets on the bottom, right? So that's something that you do. And then I'm interested in what's that cost. So if I multiply across, I get 23C. And then I can multiply 402.50 times 50 and get this number, 20,125. And divide both sides by 23. And if I divide that by 23, I get 875. So it would cost $875 for 50 tickets. Okay, so that's just a proportion, a pretty simple proportion to set up there. Okay, the next one says the number of deaths caused by the coronavirus in Washington State on March 8th was 17. On March 31st, there had been 247 deaths due to coronavirus in Washington State. What was the percent increase of deaths during that time? Round your answer to the hundreds. So first of all, whenever I want to do this and I'm asking for an increase, I want to find out what is the increase. So 247 minus 17 tells it that there was an increase of 230. Okay, that's the number, that's the change that happened, strictly not percentage wise, but just the number of deaths. So what I'm going to do is I want to find out what the percent is. So that's what I don't know in this problem. And then I want to say the change, the 230, that's going to be the top number. And then be careful about what you put down for the base, because the base is the original total. So our original total death count was 17. And so now if I cross multiply, I get 17p, and if I cross multiply here, I get 23,000. And if I divide both sides by 17, I get, wow, I get 1,352 point, what did I say, round to the hundreds, 0.94. That is a big thing, a big increase. That's over 1,000%. That's what makes coronavirus so scary, is things happen so quickly with it, and the increase is alarming. Okay, the last one is a bit of a doozy, but I think we can do it. We're going to do this in 2 steps. So Hua has a 25% discount on clothing at the store where she's a manager. If she paid $35.87, which included 8% tax, what was the original cost of the item before tax? So we're going to do this in 2 steps. The first thing I want to do is figure out what would she have paid if they hadn't added that 8% tax on. So I'm going to do this in a percent proportion. The cost of the original dress, I don't know what it, not the original one, but with her discount, let's say that cost is C. But then they added on 8% tax. 8% of that was added on, and then she paid $35.87. This item, I don't know what the item is. If you add these two together, you get 1.08 C. And then divide both sides by 1.08. And that will tell you the cost of the dress before we find out what the original cost was. So that's $33.21. I did that earlier. Okay, so that's what she was going to pay for the dress, and then they added 8% on, and she paid $35. But what we're asked is, what would she have paid before the original cost, back before she got her 25% discount? So I'm going to say X equals original cost. I obviously don't want to use O for original cost. We should have said over here C was the discounted cost, right? And then X is the original cost. So when we had the original cost, we had some cost, but we then subtracted 25% of that, because that was our discount, or her discount, 25%. And so that cost was $33.21. So we first took the 8% off that she paid to find out what she paid for the dress before tax. And then we're trying to use that to find out what was the actual original cost of that dress. And so that's 0.75x. That's 1 minus 0.25, 33.21. And now we're dividing both sides by 75 cents. Or 0.75. I don't know why I called that cents. And that gives me 44.28. So the original cost before her discount and before the tax is $44.28. That's what we're looking for. It took us 2 steps to do that, because we had to first get rid of the tax and then figure out what that discount did for her cost. All right, have a fantastic day, and I'll see you next time.